Okay, here is your homework help. Number 1, we're solving for x, looking for answers between 0 and 2 pi. We're going to divide both sides of the equation by 3. Now it might help if we have this fraction unrationalized. So let's think of it as 1 over square root 3 instead of square root 3 over 3. And picture where tangent is positive. Tangent is positive in quadrant 1 and quadrant 3. So we would have 1 on the opposite and square root 3 on the adjacent. So we have a 30-degree reference angle. So we know we're looking at, got ahead of myself, we can write this down, 3x equals the inverse tangent of 1 over square root 3. So we know we're looking at 30 degrees for one of our answers for 3x. And we're looking at 210. But remember, because we're about to divide both sides by 3 to get x by itself, we're going to want to go around the circle another 2 times. So we're going to end up with 6 answers altogether. But if you want to, you can go ahead and convert your current answers into radians first. So we have 3x is equal to pi over 6 radians and 7 pi over 6 radians. And then if you go around the circle again, you're adding another 2 pi to each of these answers. And that's going to give you 13 pi over 6 radians and 19 pi over 6. And then if you go around again, you're going to add another 2 pi to each of these 2 answers. And you end up with 25 pi over 6 and 31 pi over 6. And then finally, what we want to do is divide all of our answers by 3 to get x by itself. So we end up with x equals pi over 18, 7 pi over 18, 13 pi over 18, 19 pi over 18, 25 pi over 18, and 31 pi over 18. All right, let's take a look at number 2. All right, so we're going to divide both sides by -2. So we have cosine of 2 pi equals negative square root 3 over 2. Inverse cosine of both sides, and we get 2 pi. Sorry, that's not a pi, that's a theta. Greek letters. 2 theta equals inverse cosine of negative square root 3 over 2. So where is cosine negative? Cosine is negative in quadrant 2 and quadrant 3. Put a square root 3 on the adjacent, 2 on the hypotenuse, and we have a 30-degree reference angle. So 2 theta is equal to 150 degrees and 210 degrees. But because of the 2, we're going to end up dividing everything by 2. So we're going to go around the circle a second time and get 2 more answers. But if we want to, before we do that, we can convert our answers into radians. So we have 5 pi over 6, and we have 7 pi over 6. And when we add 2 pi to those answers, we end up with 17 pi over 6 and 19 pi over 6. And then we're going to divide everything by 2. So we get theta is 5 pi over 12, 7 pi over 12, 17 pi over 12, and 19 pi over 12. Okay, let's take a look at number 3. Tangent of 4x equals 0, so we start by taking the inverse tangent of both sides. The angle whose tangent is 0, so that would be either 0 or 180. Now, because we're going to end up dividing our answers by 4, we actually want to go around the circle a total of 4 times to get 4 sets of answers. So we would have 2 more answers from going around the circle a second time, 2 more for the 3rd time, and 2 more for the 4th time. But before we find those answers, if we want, we can convert our answers to radians. So we have 0 and we have pi. Now let's add 2 pi to each of those, and we have 2 pi and we have 3 pi. Let's add 2 pi to each of those, and we have 4 pi and we have 5 pi. And let's add 2 pi to each of those, and we have 6 pi and we have 7 pi. Now we divide everything by 4. So we have x equals 0, pi over 4, 2 pi over 4, which reduces to pi over 2, 3 pi over 4, 4 pi over 4, which reduces to pi, 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2, and 7 pi over 4. Now let's move on to number 4. And remember, when you look at this, even though it's not written in, you should see it as if the 3 theta was in parentheses. It's the only thing that's inside the sine function. So let's isolate sine of 3 theta by adding 1 to both sides and then dividing both sides by square root 2, and then taking the inverse sine to isolate 3 theta. Okay, so where is sine positive? Sine is positive in quadrant 1 and quadrant 2. We would have a 1 and a square root 2. So we have a 45-degree reference angle. And so our angles are 45 degrees and 135 degrees. And because of the 3, we would go around the circle another 2 times and get 4 more answers. But if you want to, you don't have to do that until after you convert your answers to radians. So pi over 4 and 3 pi over 4. And now we add 2 pi to each of those, and that gives us 9 pi over 4 and 11 pi over 4. And then we add 2 pi to each of those, and that gives us 17 pi over 4. And 19 pi over 4. And now we're going to divide each of those by 3 to get theta by itself. So we have pi over 12, pi over 4, 3 pi over 4, 11 pi over 4. Sorry, that was 11 pi over 12. Got stuck on the 4s. 17 pi over 12, and 19 pi over 12. Okay, let's take a look at number 5. For number 5, what we're doing is going back to number 4 and finding all solutions. So let's go back to the point where we knew that 3 theta was pi over 4 and 3 pi over 4, and let's convert that into a different set of solutions. So three theta equals pi over 4 plus 2 pi n would represent everything that's coterminal with pi over 4. And 3 theta equals 3 pi over 4 plus 2 pi n would represent everything that's coterminal with 3 pi over 4. And then we are going to divide all of those by 3. So we get theta equals pi over 12 plus 2/3 pi n. We're dividing that by 3 as well. And pi over 4 plus 2/3 pi n. Everything gets divided by 3. This, and this. They all get divided by 3. Okay, on to number 6. So we're going to start by dividing both sides by 2. And then take the inverse cosine of both sides. Okay, and the angle whose cosine is square root 3 over 2. So we're in quadrant 1, we're in quadrant 4, square root 3 on the adjacent, 2 on the hypotenuse. We have a 30-degree reference angle. So if we were answering in degrees, our answers would be 30 degrees and 330 degrees. And remember that we're about to multiply both sides of the equation by 4, so we actually only want to go around 1/4 of the way around the circle. And so that means we really could only go from 0 to 90, and so we have to eliminate the 330, because now we're going to multiply by 4. If you want to, now you can convert to radians. X over 4 is equal to pi over 6. And now multiply by 4, and you get 4 pi over 6, which is 2 pi over 3. So you see that if you were to take the previous answer, 330, and multiply it by 4, you get something that's way beyond the limits of the interval we were given. Oh, were we given an interval in this one? Oops. Okay, my bad. I didn't look at the directions, so I just undid some of that. So for this one, we're looking for all solutions. We don't have an interval. And so we don't have to eliminate anything. So what we want to do is write this as, well, radians still. We have pi over 6 plus 2 pi n to represent all the infinitely many angles that are coterminal with 30 degrees. And then we have 11 pi over 6 plus 2 pi n to represent all of the angles that are coterminal with 11 pi over 6. And now to get x, we're going to multiply everything by 4. So 4 pi over 6 would be 2/3 pi plus 8 pi n. You have to multiply that by 4 as well. And then the other one would be 44 over 6 would be 22 pi over 3 plus 8 pi n. Okay, and now we have number 7. Okay, we're back to having an interval, right? 0 to 2 pi. And the thing that I like about this one is we finally get a chance to do something with cotangent. So we've only been doing sine, cosine, and tangent in all of our equations so far just because, hey, it's a pandemic and we can't do as much. So I had to figure out what to let go. But we know everything we need to know to be able to do this. Okay, so let's take the inverse cotangent of both sides. So think about it. Where is cotangent -1? So where's tangent -1? That would be quadrant 2 and quadrant 4, and you would have a 1 and a 1. So that would be a 45-degree angle. So we have 3x is equal to 135 degrees and 315 degrees. But because of the 3, we're going to end up dividing everything by 3. So we're going to go around the circle 2 more times for a total of 3 times. So 2 more answers for the second time around, 2 more answers for the third time around. Let's convert these into radians. So we have 3 pi over 4 and 7 pi over 4. And then adding another 2 pi, we get, what would that be? 11 pi over 4 and 15 pi over 4. And then taking those and adding another 2 pi, we get 19 pi over 4 and 23 pi over 4. And then we're going to divide all of those answers by 3. So we have pi over 4, 7 pi over 12, 11 pi over 12, 5 pi over 4, 19 pi over 12, and 23 pi over 12. And that takes us to the end of the homework. Yay!